So let's do now a couple of problems with multiple forces in there, just to go over how those forces are going into this sum of the forces equals ma Newton's second law. So here I have an airplane that can exert, whose engines can exert 11,700 newtons of force apiece. It's a dual engine airplane. And I give you the mass, 15,000 kilograms. So that's how large the jet is. So it takes off, and I want to know how long is it going to take to reach cruising speed of 270 meters per second. Careful though, there's a headwind, so there's a force coming against it, 1,000 newtons. So let's draw a free body diagram here. I'm going to have the force of two engines, so I'll label that Fe and then another Fe, right? Because I have two engines, so maybe 2 and 1 there. And then coming back the other way, I have air friction, right, or force of wind, I think is how I described it in the problem. That was a headwind. So the wind is coming back the other way. In the y-axis, I have gravity going down, right? You always have gravity for anything occurring on Earth. And then what's opposing gravity? Well, it's the lift of the airplane's wings. So I'll put that as maybe F lift. Notice how when I'm drawing my free body diagram, I drew these two and the y-axis to be the same because I'm assuming the plane is flying along at cruising altitude. Now technically, lift is probably going to be larger than the force of gravity because the plane's going to be rising there, but I'm not going to worry about that in this problem. All I'm going to worry about is the x-axis, the engines overcoming the wind. Okay, check it out. The two vectors for your engines are longer than the force of the wind. So now let's actually start solving this problem. We are only worrying about the x-axis here. So some of the forces in the x-axis, I apologize for that terrible looking sigma, is going to be, I didn't label positive and negative. I want to call this way positive and that way negative. Up positive and down negative. So I'm going to have force of engine 1, Fe1 plus Fe2 minus the force of the wind, Fw equals ma. All right, great. Now I can start plugging in numbers, right? So Fe1 and Fe2 are both 11,700. So that's actually 2 times 11,700. That's what these two, Fe, F1, are. So I'm just combining them into one thing. Minus the force of the wind, which is 1,000 newtons, equals my mass, which is 15,000, times A. When you work this all around, A is going to equal 2 times 11,700 minus 1,000, all divided by 15,000, which will give you A is 1.49 meters per second squared. Now that's not the final answer because it didn't ask for the acceleration. I just knew I need to look for it. Instead it asked for how long will it take the plane to reach a cruising speed of 270 meters per second. So think about it. The plane starts off with a VI, let's kind of create a little section here, VI equal to 0. And I want to get up to a VF of 270 meters per second. I also know that I'm solving for time. The thing is, though, that's not enough information. So I kind of got ahead of myself here, and I went ahead and solved for A, because I know I'm going to need that information, 1.49 meters per second squared. Now I have enough information to pick a kinematic equation and solve. So let's use VF equals VI plus AT. Plug in 270 equals 0 plus 1.49 T. So you divide both sides by 1.49 and you come out with T equals 181 seconds, but I only have 3 sig figs here because it's actually 181.2, but check it out, 3 sig figs, a whole bunch of sig figs, a whole bunch of sig figs, 2 sig figs right there, so I can only do 180 seconds. Now, is this reasonable? Well, yeah, it's a little slow if we're running at maximum speed, but in case you haven't noticed, whenever you fly on an airplane, they're not instantly up to their maximum speed. It does take a little while, and this plane, quite apparently, I made the engines not as strong as they should be. Recently, a very sad event has occurred. A super typhoon, Category 5, the largest, probably the largest typhoon that has ever made landfall in the entire world, absolutely decimated the Philippines. And so right now there's this massive effort to try to get relief in because the number of dead is huge, and now the people who are there, they have no power, they have no water, they have no food, they have nothing left. So there's a massive relief effort to get in. So here's something that actually is occurring. The military and other organizations are using Chinooks, large helicopters that are very useful because they can carry a massive payload. So they can carry tons of medical supplies, tons of food into the areas that are needed. They're also very useful because of the vertical landing and vertical takeoff, so they can actually get to spots that you can't get to very easily on land or with an airplane. So helicopters are incredibly useful for that, and Chinooks, they're the ones that can carry the most. So here I have a Chinook helicopter taking off to bring supplies to the typhoon victims. The mass of the helicopter is 11,000 kilograms, and the helicopter has a maximum lift force of 210,000 newtons. And so my question is, if we're going to give it everything we got, how much medical supplies can it carry? What mass of medical supplies can this helicopter carry? So let's do a free body diagram here. I have going down the force of gravity, and I'm going to force of gravity of the helicopter, okay? I have going up the force, the maximum lift force of the helicopter. Also coming back down, we're going to load this helicopter all the way up as much as we can, equal to the lift force with medical supplies. So force of gravity of M medical supplies, all right? So what is the maximum mass of medical supplies we can carry? Whenever you find one of these type of problems, and by the way, this is all on the y-axis here, whenever you find one of these type of problems, your acceleration is going to be 0. Whenever you're trying to max it out, you only need to accelerate a little bit upward. So technically, I guess we should be 1/10 of a gram less, or even less than that, than the number we're about to come up with. But under ideal circumstances, if you're already in the air, this would keep you afloat. Remember Newton's first law, an object in motion remains in motion, right? So sum of the forces equals ma. I called up positive and down negative. So this means the force of lift minus force of gravity of the helicopter minus force of gravity of the medical supplies equals ma. And since we're just trying to keep it we're just trying to stay in the air, we're not worrying about trying to accelerate upwards. We're looking to max it out as best as we can. The acceleration here is 0. We're not looking to fly accelerating up in the air. We're just trying to maintain altitude, so to speak. So acceleration is 0. That means the entire right-hand side becomes 0. Force of lift, we're told maximum, is 210,000 newtons minus the force of gravity for the helicopter. That's m of the helicopter, mass of the helicopter, times gravity here on Earth, minus gravity, force of gravity of the medical supplies. That's mass of the medical supplies times gravity here on Earth. So continuing to solve this around, 210,000 minus mass of the helicopter is 11,000 times 9.81 minus mass of the medical supplies is what we're looking for, M medical, times 9.81 equals 0. Now this is a good time for me to double back here and point out that I used positive 9.81, not negative 9.81, even though I called down to be negative. Reason for that is I have already taken into account direction by making it minus mg, minus the force of the helicopter, minus mg. I have already given the negative sign on it. Now if you make this negative 9.8, even after you've already dealt with the direction of this entire force, you're going to have a negative times a negative, making that a positive. saying that this force of gravity on the helicopter is going up, which is not true. So you don't want to make this negative 9.8 after you have already dealt with direction of the force. All right, so now it's just a little bit of algebra. So I went ahead and just quickly worked out the algebra there for you, and whenever you get to your final answer, you'll see that with significant figures, because you only get 2 in this problem, you get 10,000, I got to put a bar there, 10,000 kilograms of medical supplies. That's kind of the point of the Chinook. It can carry almost, if not exactly, its own weight in supplies, which is why it's so crucial in the relief effort.